Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. With this question you just need to know the names of 3D shapes. This one is called a cylinder. In this question we're given the output as 53. So we know that the output was 53. So now we've kind of got to work backwards. And when we work backwards through a function machine or a number machine, we do the opposite of what it says. So this first one says plus 9, but when we go backwards we do the opposite, which is take away 9. So we do 53 take away 9, which is 44. Now we can check that by going the other way. So 44 plus 9 is 53, so that works. The next one says times 4, so the opposite would be divided by 4. So we're going to do 44 divided by 4, and that gives us an input of 11. Now let's check the whole thing. We put in 11. 11 times 4 is 44. 44 plus 9 is 53, so we know we've got it correct. So we can write the factors of 6 by working out two numbers that multiply together to make 6. So 1 times 6 and 2 times 3. So 1, 2, 3 and 6 are all the factors of 6. The only number that is in our list is the 2. So we're going to start off by writing the sequence out. And what you might notice straight away is that each of the terms is increased by 2. And so we're asked to find the next two terms. So we're just going to keep this pattern going. So increase it by 2, that would be 20. Increase by 2 again, and that would be 22. So we're going to start by writing 5 over 9 as a decimal. And to do that we just need to do 5 divided by 9. Which will be 0.5 recurring. And to convert between a decimal and a percentage, we just times by 100. So we're going to get that 0.5 recurring, and we're going to times it by 100, and that will equal 55.555 recurring. And to the nearest percent, that's going to be 56, because that 5 will move that 5 up by 1. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911. And divide it by the 71 to find out what one part is worth. How many students are in one part? One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together you get 2,091. So our answer is that 2,091 students responded with yes. Here we've got angles on parallel lines, and if I connect the angles up you can see that it kind of makes a bit of a Z pattern there. And we know that Z angles that are always equal. So X will be just 163 degrees. Now the key is figuring out Y. The reason why I remember is because they're alternate. Okay? I just put the letter Z in alternate to remind me that's what it is. The actual reason is not with a Z in, it's alternate. But I always remember alternate, just bung the Z in there and try and remember that anytime you have these Z angles, then they are alternate. I'm going to start by working out what the building is, or the width of the building is in centimetres. So it says 33 metres, and I'm going to convert that into centimetres by timesing by 100. Okay, now when it says it has a scale of 1 to 300, it means 300 in real life is 1 on our map. So all I need to do is divide it by 300 to find out what it's going to be on our map. So we'll just divide that by 300 and I get the answer of 11. So it's going to be 11 centimetres on our map. So firstly we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, sorry, and so that would be 101.2%, and we divide that by 100 to make it a multiplier. So the multiplier is 1.012, so we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane. And so let's do Lenny. And so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100. Which give us 1.015, and then finally what we do is we get the 17,000 times it by the multiplier, and when we do that we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. Let's rewrite this expression but with a time sign in, so V times W squared. Now W squared just means times by itself, so we can rewrite that as V times W times W. Okay, so we know V is minus 10, so minus 10, and we know W is minus 4, so it's times minus 4 times minus 4. Okay, so when you multiply, it doesn't matter which order we do it. So what I'm going to do is I'm just going to do these ones first, and I'm going to ignore that times minus 4 at the end. So minus 10 times minus 4, that's a minus times a minus, which is a positive, 10 times 4, which is 40, times minus 4. Now we're going to do 40 times minus 4, so it's a positive times a negative, so that's going to be a negative. And 40 times 4, well, 4 times 4 is 16, so 40 times 4 is 160. So it's going to be minus 160. So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 metre and the 35 metre. And essentially what this question is asking is what is the highest common factor of 25 and 35. So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5. And the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4. Not to scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 metre long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. Whenever we do these kind of questions, it's always best to convert the pattern into numbers. So we're just going to count the dots. So we've got 2, 4, 6, 8, 9 in the first one. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So our sequence is going 9, 13, 17. And we're going to see what it's going up in. So we're adding 4 each time. And that means our sequence will involve 4n. And then what we do is we go backwards 1 to find the 0th term. So we're going to take away 1. So 9 take away 1 is 5. So the 0th term is 5. And the 0th term just tells us what to add on to the 4n. So 4n plus 5 will be our answer. To find solutions for quadratics on a graph, all you need to do is find out where the graph meets the x-axis. Okay, so the coordinates this graph meets the x-axis are here, and that would be minus 0.8 and and 0.2, and they're also called roots. So we're just going to substitute the values that were given into the formula. So v squared equals, and then u is 16.4 squared plus 2 times a, which is 0.2, times s, which is 110.2. Type that into the calculator and you get 313.039 blah blah blah. And what we're going to do is we're just going to quickly solve this by square rooting both sides, because it's v squared equals and we just want v equals. So v equals, and we're just going to square root that on the calculator, 17.692 blah blah blah. It says it wants it to 2 decimal places, that's just going to be 17.69. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon. And this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. The first thing we can do is work out what the circumference of the full circle would be. Obviously we haven't got a full circle here, but what the circumference of the full circle would be had we got a full circle. So that's going to be pi times the diameter. The diameter is twice as big as the radius, and this 21 centimeters here is the radius of a full circle. So that's going to be pi times 2 lots of 21, which is going to be 42 times pi, which is going to be 131.946 blah blah blah. Now we don't have a full circle here. We've got to work out what fraction of a circle we have. Well, we obviously have a quarter of a circle. So to find the arc length, which is this part here, it's like a part of a circumference, to find the length of the arc, what we're going to do is just get that circumference and we're just going to divide it by 4. So we're going to get the 131.946 blah 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 and divide it by 4. When we do that, we get 32.986 blah blah blah. Now that's not what the perimeter is. Perimeter is the total distance around the circle. So we've also got to add on the 2 parts here, the 2 radii here, to get the full distance around the circle. So the perimeter is going to be the arc length plus a radius plus a radius. So that's going to be 32.986 blah blah blah, plus 21 plus 21, which equals 74.986, blah blah blah. And when we round that to 2 decimal places, we get the answer of 74.99. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10, 990. Now when we're looking at limits with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So we're asked to find 3a minus 2b. So let's work out 3a first. 3a is going to be the top times 3 and the bottom times 3. So the top times 3 is 9, bottom times 3 is 6. Then we're going to work out what 2b is. Again, times the top by 2, times the bottom by 2. And so 3a take away 2b is going to be 3a, which is 9 at the top, take away, and then the 2b, which is minus 2. And then the bottom will be 6, take away, minus 4. And so that's going to be 9 plus 2, which is 11. 6 plus 4, which is 10. So the vector is going to be 11 at the top, 10 at the bottom. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.